Hey everybody. So this morning we woke up and Brett is really sick, and as usual things aren't going the way I expected. So you know what? We're gonna go with it. Um, our goal today, what I expected us to be doing in class, is for us to be discussing quadratic functions. Quadratic functions. Everything Um, all of us should know that quadratic functions are anything in the form of ax squared plus bx plus c. We want to know all the different parts of quadratic functions, and we want to just talk about the basics of quadratic functions today. Um, so we are going to start with our quadratic function questions. I have one sitting up here. We're going to just kind of bounce back and forth of the different parts of quadratic functions, and then I'm going to give you a few to practice, and hopefully I won't get sick today, and Brett will be feeling better, and I will be back tomorrow. So quadratic functions are something that, like we said, are in the form of y equals ax squared plus bx plus c. If we go, this is our constant term. We have just our constant term. That means all we have is a horizontal line or a vertical line. Well, if it's just y equals, then y tells us we have a horizontal line. This is our linear term. Anything that's in the form of y equals mx plus b, that's going to give us our linear function. And this is our quadratic term. Sorry. So if it's quadratic, we know it is a parabola. We know that it's going to be U-shaped. And it's going to be either parabola up or parabola down. If it is parabola up, we can immediately recognize that it is going to be parabola up if our a is greater than 0. We know that it is parabola up if a is greater than 0. And we know that we are going to have a point down here at the bottom, and that is called a minimum. And it is parabola down if a is less than 0, meaning that it is a negative number, and that gives us a maximum. Now all of us should know that this point has a special name that I'm referring to. The point that is either a minimum or a maximum is called your vertex. And we have to be able to find the vertex. That's the very important part of our parabola. The vertex, the minimum or the maximum, is incredibly important. Quadratic functions are found in nature. We talk about finding things that rise and fall in a quadratic relationship all the time. And so we try to find those maximums and minimums constantly. And so we're always trying to find that vertex. And in finding that vertex, we're looking for that particular point. We're looking for the coordinates of that point. We're looking for that relationship. And so really important for us to find that maximum and minimum. Now, if we look at this particular function, y equals x squared minus 4x plus 3, it is in the form of y equals ax squared plus bx plus c. Our a is found right in front of the x squared. In this case, we don't have a number. We have an understood 1. That 1 is positive, so our a is positive. This lets us know that if we were to graph this function, it would be a U-shaped parabola. A touchdown is what I used to call it last year, and so we have a minimum. Now, the next question that we have here says, what is the axis of symmetry? Now, the axis of symmetry, if you remember, we talked about our parabola. Here we have a parabola, and all of our parabolas are symmetrical. Every single one of the parabolas that we graph are going to be symmetrical about a line. And that line that goes right down the middle, and I know that I am not a fabulous drawer, artiste, but that line that goes right down the middle is our axis of symmetry. So our axis of symmetry is where our vertex is always going to be. Our vertex is always going to be on our axis of symmetry. And our axis of symmetry is always going to be found with x equals negative b over 2a. We can always use negative b over 2a to find our axis of symmetry. The cool part about that is since our vertex is always on our axis of symmetry, the x-coordinate of our vertex is always going to be negative b over 2a. And so that allows us to take that coordinate for x, plug it back into our function, and find the y-coordinate. So if we can remember this relationship, it's really important to finding that vertex. The axis of symmetry, however, is a line. It is a vertical line. So if I ask you for your axis of symmetry, I am looking for an equation of a vertical line. So you must put x equals a number, not just a number. So we're looking for x equals negative b over 2a every time we're finding an axis of symmetry. So for this particular problem, if you're looking for the axis of symmetry, it is x equals negative b over 2a, or in this particular case, our a is equal to 1, our b is equal to negative 4, and our c is equal to 3. So we would plug in negative 4 over 2 times 1. A negative times a negative is a positive 4 over 2, which is 2. So x equals 2. That's my axis of symmetry. That means at the line x equals 2, the entire parabola is going to be symmetrical about that line. Now, if we want to find some other coordinates, we can draw, or we can plug in to our equation and find some other coordinates. It's actually really smart to start with our axis of symmetry, because then we can go from left to right. We can find our vertex and then go from left to right on that, around that axis of symmetry, and we don't have to just randomly pick coordinates and not be sure exactly whether those coordinates are going to be near our vertex. Finding your axis of symmetry first is probably one of the best things that you can do. So, we've already discussed our vertex and the fact that the vertex is probably the most important part of our parabola. If we know our axis of symmetry is at 2, then we already know the x-coordinate of our vertex is 2. We know that somewhere on this line our vertex is going to fall. So we can take this 2 and plug it in so that y equals x squared minus 4x plus 3. And then we can, you know what, I'm going to scoot it over here to save myself room to find the x-intercept. We have y equals x squared minus 4x plus 3. And then I plug in 2 squared minus 4 times 2 plus 3. Well, that gives me 4 minus 8 plus 3, which is negative 4 plus 3, or negative 1. So the coordinate 2, negative 1 is my vertex. My y-intercept is, if you think about your y-axis, all of these coordinates have an x of 0. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6. So that means we're going to plug in a 0 for the x. If you plug in 0 for the x squared and 0 for the x, so negative 4 times 0 plus 3, then you're just going to be left with 3. So that means we're going to be at 0, 3. So now I have 2 points here graphed, and I need a few more to figure out what my parabola would look like. If I used my symmetrical, what I know about symmetry, if I have a point here to a distance of 2, then I should have one here. That means if I plug in a 4, I should have 3. We can make a table of x and y, and if I plug in 4, well, 4 squared minus 4 times 4 plus 3 would give me 16 minus 16 plus 3, so that's right. That does equal 3. We can plug in 1 and get 1 squared minus 4 times 1 plus 3. 1 squared minus 4 is negative 3, and negative 3 plus 3 is 0. And if we plug in 3, 3 squared is 9, and then we get negative 4 times 3 is negative 12, plus another 3 is 0. So here, we're getting my parabola. Looking pretty good. If you graph this particular parabola, it's very obvious that you have x-intercepts at 2 and at 3. Just by plugging in, you can find your x-intercept at 2 and at 3. I just plugged in some points for x, and I found my x-intercept. Today, what I want you to do to find your x-intercept, just because we are so fabulous at it, and because I only have 30 seconds left, is negative b, plus or minus root of b squared minus 4ac of b squared minus 4ac all over 2a, all over 2a. I think you can do it. I want you to try it for me. I'm sorry that I don't have a whole lot of time left. Plug that in It should simplify to give you 2